Okay, good morning. Today's topic we have chosen for creating the video is bourdon gauge. This is for mechanical student, for third year mechanical students. Okay, today's topic is bourdon gauge. This gauge is used for measuring medium to high pressure. It could be fluid, it could be gas, or anything. Okay, this is used to measure medium to high pressure. So this is how the bourdon gauge looks like. So this is where if you would have seen the practical applications, you would for any pump set, or any pressure lines, these gauges will be fixed. All these gauges are used to measure the pressure, that is the flow pressure of a pipe. If in a pipe a fluid is flowing, so what is the flow pressure at any point or at any place in a pipe, it can measure with this bourdon gauge. So now if you see the construction of the bourdon gauge, how it is, it consists of a seamless tube having elliptical cross section. So this is the tube which is having elliptical cross section. The tube is supported in a socket which contains the inlet pressure. So this tube and the socket is the build one which is welded together, and this is the inlet port. This is the inlet port pressure connection. This is the socket, and this is how it looks like. So this is the pictorial view. This is how it looks like. The free end of the tube is called tip. This is the tip. The tube and the socket are welded together, as I have said before. The wall thickness of the tube ranges from 0.5 mm to 1.25 mm. 0.5 mm to 1.25 mm. The free end of the tube tip is connected to a spring. This is the spring. This is a spring here. If you could see, this is the hair spring. It's in the form of, it's in the circular form, connected to a spring loaded linkage which amplifies the displacement and transmits it to the angular rotation of the pointer. So this spring helps in moving the pointer around the tube, and this pointer lies on the gauge. There is a dial gauge, okay, which shows the pressure. If you could see here, this is the gauge readings in psi 20, 40, 60, 80 and 100. So this is the dialer which shows the pressure, and this dialer will move with the help of this hair spring. And how this hair spring is activated? With the help of a sector gear and pinion mechanism. So this is the pinion mechanism, and this is the sector gear. If you could see here, this is the gear and this is the pinion mechanism. Now all the gauge components are kept enclosed in a casing. In a complete casing, it is enclosed. If you could see here, you could see the pointer, you could see the gauge and the dials and everything in a mechanism, in a enclosed casing. So when the pressure is applied at the end of the socket of the bourdon tube, this tube tip deflects. Why? Because once the fluid enters into this tube, this elliptical tube becomes circular, and this elliptical tube will become circular, and it will activate the hair spring. Once the spring is activated, the sector gear and the linkage, because of the linkage, the sector gear will move the pinion, and then in turn the hair spring, and then the dialer will move on a scale. So like this, the dialer will move on a scale. So this shows us the reading, the pressure at any point in a pipeline. So this is connected to a pipeline, and next we will see an animation regarding how it looks like when the pressure fluid flows inside the socket. So this is bourdon pressure gauge. Okay, so this is the pressure gauge connected to a pipe. It is an electric transducer which is fixed at one end and receives the pressure which is to be measured. So this is the dialer which I have told you before, and this is the dial. And inside, if you take a look inside the construction, the socket is here, and this is the tube, and this is the tube which is connected to the socket, welded to the socket, and these are the gears, the pinion gear and the sector gear. This is the bourdon tube which I have told you. So now what we are doing is we are letting the fluid come into the socket. We are letting the fluid come into the socket. Now if you see, this blue color thing is the fluid. Okay, now once the socket is filled, the fluid is entering into the tube, and then the tube, this elliptical tube, will become circular, and then because of the linkage, the sector gear and the pinion will make the pointer rotate to a new position. Pressure calibrated scale to indicate the applied pressure directly. So once if the pressure is reduced, that is the fluid flow is taken out, so again the scale will return back to its normal position. So it is capable of withstanding the pressure, and then it can continuously show the pressure, or it can continuously show the fluctuations based upon the pressure of the fluid. Okay, now coming back to the slides. So this is the working of the bourdon gauge and the construction. So now if we coming to advantages, so this pressure gauge gives accurate results. They cost low. They are simple in construction. They can be modified to give electrical outputs. They are safe even for high pressure measurements. Accuracy is high, especially at high pressure gauges. And coming to the materials, where this bourdon pressure gauge materials. Okay, so the tube material, this tube material is made of bronze, beryllium, copper, and steel. So generally, it is made of bronze for the industrial purposes. But the tube material will be changed based upon the pressure it measures. So now the bronze will be used to measure the pressure below 600 psi, and beryllium copper will be used to measure the pressure below 10,000 psi, and to measure the pressure above 10,000 psi, steel tubes are being used. Okay. So this is regarding bourdon gauge. So this is useful for third year students, mechanical.